Hello everyone, welcome to Learn Spring Boot with Bingyang. In this video, let me show you how to upload files to Azure Blob Storage from a Spring Boot application. First, let's revisit a user story of our Hogwarts Artifacts Online project. Look at this user story in the Artifact Management feature. As a logged-in user, I want to add an artifact so that we can keep track of this new artifact in the magic world. Recall that to implement this user story, we came up with this API endpoint. When a user is adding a new artifact to the database, she needs to make a POST request and provide the artifact name, description, and an image URL. Although we have implemented this API endpoint in a previous video, there's one thing I skipped. That is, how do we get this image URL in the first place? To give you more intuition, let me show you one front-end design for adding an artifact. This HTML form allows a user to enter the artifact name and description and upload the artifact's image. Optionally, the user can select the owner of this new artifact. So, what's going on behind the scenes? It turns out that after entering the name and description of this new artifact, we can click this plus sign, select an image, and upload it to a blob storage server. So this is an API call before the add an artifact API call. If you're all familiar with the term blob, it stands for binary large object. Essentially, it's a way to store large amounts of unstructured data. This can be anything from text and binary data to images, videos, and documents. Azure Blob Storage is Microsoft's object storage solution for the cloud. When the upload request is successful, the blob storage server returns an image URL, like this. The form then renders the uploaded image. To indicate the image has been successfully uploaded, please note that at this point, the artifact rememberable is not added to the MySQL database yet, but its image has already been uploaded to the blob storage server. Finally, we can invoke the add an artifact API endpoint to add an artifact. As you can see, this is the payload of the add an artifact API call. So this is the complete process of adding an artifact. In this video, this part is what we're going to implement. Next, let's follow the API first approach and define a new API endpoint for uploading an image file. Let's go to Swagger Hub. I have already added a new endpoint /artifacts/images to our Swagger API document and upgraded the document version to 3.1.0. The link to this API document is available in the description of this video. As you can see, the content type of the request body is multipart /form-data. There are two form data values that the front end needs to provide to the backend: the name of the blob container and the image file. If the image is uploaded successfully, this is the response. As you can see, the data contains the image URL of the uploaded image. To implement this uploading artifact images API endpoint, we need to complete several tasks. Let's go back to the slides. First, we need to set up the Azure Blob Storage by creating an Azure Storage account and a blob container. Second, we need to configure Spring Boot application so that it connects to the Azure Blob Storage. Third, in the Spring Boot application, we need to write code to receive the image file from the front end and then upload it to Azure Blob Storage using Spring Cloud Azure module. Let's work on them one by one. First, let's set up the Azure Blob Storage by creating an Azure Storage account and a blob container. Let's go to the Azure portal. First, let's go to Storage Accounts. And you can search it here. Storage Accounts. This one. And let's create a new storage account. Here, pick your subscription, and here, pick a resource group. In my case, I will select Hogwarts Resource Group. Then, let's give this account a name. Hogwarts Artifacts Online. Great. The storage account name must be unique, so you will need to pick a different one. Then you need to pick a region. Make sure the region is close to your potential customers. For performance, let's use the standard one. For redundancy, let's pick the locally redundant storage for tutorial purposes. As you can see, this is recommended for non-critical scenarios, and is also the cheapest one. Pick others as you see fit. Let's go to Next. In security, let's check Allow enabling anonymous access on individual containers. Later on, we'll create one container to hold all the artifact images. We want this container to be publicly accessible, so make sure you check this option. Everything else will be fine. Let's go to Next. The default ones are good. Next. Then Next. Next. Review and create. This may take a few minutes. Okay, let's go to resource. So the storage account is created. Next, let's create a container in this account. So let's go to containers. And let's click new container. So what is a container in this context? To be more specific, what is a blob container? A blob container organizes a set of blobs. Think of it as a directory in a file system. In Amazon AWS, a container is called a bucket. A storage account can include an unlimited number of containers, and a container can store an unlimited number of blobs. So let's create a blob container for storing the artifact images. So let's call this artifact image container. And the change is anonymous access level to blob. Anonymous read access for blobs only. Recall that in our Hogwarts Artifacts Online application, all the artifact data are publicly available. You do not have to sign in to access all the artifacts. Pick the right anonymous access level as you see fit. All right, then let's click Create. Let's click this container. Now that we have this container, we can upload files to this container. I can click Upload, Browse for files, and let me find one image. And I can click Open, then click Upload. All right, then it's there. So let me click this image file. And here is the image URL. So let me click Copy, and then go to here, Paste. As you can see, this is the image URL for this artifact. Now it is publicly accessible. And if I press enter, okay, now it shows in my browser. If you know HTML, you can use an image tag to render this picture nicely, right? Okay. Look at column 3, access tier. The blob data in a container is organized based on how frequently it will be accessed and how long it will be retained. Azure Storage offers different access tiers. Hot tier is an online tier optimized for storing data that is accessed or modified frequently. The hot tier has the highest storage costs, but the lowest access costs. For infrequently or rarely accessed data, Azure Storage offers the cool, cold, and archive tier. They have low storage costs, but high access costs. Okay, so I just showed you how you can manually upload files. But of course, we need to do this programmatically in Spring Boot. So far, we successfully set up the Azure Blob Storage. Next, let's configure our Spring Boot application so that it can connect to this Azure Blob Storage. Let's go to IntelliJ. Let's create a Git branch first. Artifact, image, upload. Git, switch. Okay. To support Azure Blob Storage in Spring Boot, we need to install the Spring Cloud Azure Storage Blob Starter module. So let's add a new dependency in the pom.xml. Dependency. The group ID is com.azure.spring. And the artifact ID is Spring Cloud Azure Starter Storage -blob. Let's click Load Maven Changes. Spring Cloud Azure is an open source project that provides integration between the Spring applications and Azure services. Actually, we have already used it before. Do you remember Azure Key Vault? We used Azure Key Vault to store the MySQL database credentials. As you can see, they share the same group ID, com.azure.spring. Okay. Recall that we added this Spring Cloud Azure Bill of Materials, or BOM, in an earlier video when we connect the Spring Boot application to the Azure Key Vault. If you don't have this in the pom.xml file, you must add this dependency management as well. The version here is defined as a POM property, so let's go there. Right now, the Spring Cloud Azure version is 5.7.0. Let's upgrade it to its latest version, which is 5.13.0. Every time Spring has a new version, Spring Cloud Azure will also upgrade to a new version. So if you are watching this video from the future, there will be a newer version. I included a link under this video for a reference, so you know which version to use. For now, it is 5.13.0. Okay, so much for pom.xml. To connect to the Azure Blob Storage, we need to set the storage account name and key in our Spring Boot application. Where do we set those credentials? Yes, in the application.yaml file. So let's go to src, main, resources. Well, there are actually 3. Which one do we use? So here is what I'm going to do. Since the application is under development now, let's use the application-dev.yaml. So now we're in the dev mode. Later, I will show you the configurations for the production mode. To configure the application-dev.yaml file for Azure Blob Storage in our Spring Boot application, we need to set the necessary properties for connecting to the Azure Storage account. So here are 2 important properties we need to configure. The first one is Azure Storage account name. Cloud, Azure, and thank you, Copilot. We got account name and account key. As you can see, we're supposed to store them in environment variables. So let's go to Edit Configurations and add these 2 environment variables. As you can see, right now, there's already 1 environment variable, AI OpenAI API key. So let's click Add, Azure Storage account name. And we know the value is Hogwarts artifacts online. Yours is different from mine. Okay, then the second one, Azure Storage account key. Then what is the value? Let's go back to the Azure portal. So here is the storage account, Hogwarts Artifacts Online. And let's click Access Keys. All right, as you can see, this is the account name. We already set it as an environment variable in IntelliJ. Now there are 2 keys, and let's pick the first key, copy, and then let's go back to IntelliJ and paste it here. Okay, let me remind you, the Azure Storage account key is a secret. Please keep it properly. All right, then let's click OK, click Apply, and then click OK. All right, now our Spring Boot application knows where to retrieve the 2 values, the account name and the account key. It will retrieve them from the environment variables. Okay, good. Now, as a good practice, let's also set default values for these 2 environment variables. Your account name, your account key. Okay. Sometimes we want to control the maximum file upload size. Spring provides 2 useful properties that we can add to this YAML file. So the first one is Spring Servlet multi-part max file size. By default, it is 1 megabyte. And here, I'm going to set it to 2 megabytes. The second important property is called max request size, meaning the max total request size for a multi-part form data. By default, it is 10 megabytes. And here, I will set it to 20 megabytes. Okay, at this point, we have set up the Azure Blob Storage and configured the Spring Boot application. Next, let's write code to implement the upload artifact images API endpoint. Let's go to the artifact controller class. So let's define a controller method for this API endpoint to receive the image file and upload it to the blob storage. According to the API documentation, this is a post mapping. So at post mapping, images. Let's define this method. Public result upload image. According to the API documentation, the front end will send an HTTP request with two form data, the blob container name and the image file. So how does this controller method retrieve them? Thanks to Spring MVC's data binding capability, we can easily get the two form data using two method formal parameters. So let's define two formal parameters. One for the container name and the other one for the file. Multi-part file. But this is not enough. We need to use the @request_param annotation to bind the form data in the request to this method's formal parameters. Okay, let me explain. Spring provides support for HTTP multi-part file uploads. It automatically binds the file to this multi-part file formal parameter, so we can use it inside the controller method. The multi-part file here allows us to access details about the uploaded file, such as its name and type. For example, here I can type file dot. We can get the bytes of the file, get the content type, input stream, name, size, original file name. We can even tell if this file is empty or not, or transfer it to a given destination file. For example, we can transfer it to the local file system of the server. But in this case, we're not going to use it because we want to upload it to the Azure Blob Storage, right? Okay, next, let's upload this file, this image file, to the Azure Blob Storage. Let's first get input stream from the multi-part file object. File.get input stream. And here, let's just throw the exception. Then, which object is responsible for uploading this image file? Well, you probably think of the artifact service object. And look at here, that's exactly what Copilot recommends. Since we have used this artifact service object to find, add, update, and delete artifacts, right? Yeah, we could define the logic of uploading files in this artifact service class. However, since it is possible that other components of this application may also want to use this image uploading service, so it's better to create a new object for this task. So next, I will create an image storage client for uploading image files. In a previous video, I created this client package for the external services we use. As you can see, right now, there is an AI chat client already defined here. Now, let's create a second client for image uploading. First, let's create a sub-package under this client package. And let's call it image storage. Oh, by the way, I want to briefly explain this terminology client. I prefer to call an external or third-party service a client instead of a service to differentiate from the services defined by us. For example, artifact service wizard service, and user service. So those are defined by us. But everything here, we're using third-party services. In other words, services that are beyond our control. So even though artifact service, wizard service, user service, and these two clients, they all provide some kind of services to the consumers, the difference is that we have the full control of those services. But we are the clients of, for example, OpenAI API or the Azure Blob Storage SDK. So I hope you can understand this subtle difference or nuance. But this is totally my personal preference. Feel free to call it whatever you want. Okay, so let's come back to the image storage. To make our application more flexible, I'm going to adopt a good object-oriented programming practice called programming to the interface. So take a look at this picture. I'm going to define a Java interface called Image Storage Client. This interface offers a uniform interface for interacting with different image storage services. For example, it can have one implementation for Azure, but it can also be implemented for other image storage services like Amazon's AWS image storage. Can we add support for other vendors like Google's image storage? Sure. Just create another class that implements this image storage client interface. So the benefit of this design is that by having our artifact controller depend on this abstract image storage client interface, instead of a concrete image storage implementation, we gain the flexibility to adapt to alternative image storage services in the future. So if we no longer want to use Azure Image Storage Client, we can simply swap it out and swap in, say, AWS Image Storage Client. The code of Artifact Controller does not need to be changed. So in summary, this image storage client keeps the code in Artifact Controller stable. So this is a very good object-oriented programming design. Okay, so let's go ahead and create this image storage client. All right. And we do not need the second method. Thank you, Copilot. So here, the first parameter is container name. We need to know where to upload this image, right? And then we need the second parameter, original image name. And third one is the input stream of this file. Let's give it a different name called data. And the last one is the length of this file. Okay, good. Next, let's introduce this interface into Artifact Controller. So let's scroll up. Private, final, image storage client. And then let's add constructor parameter. So when Spring Boot is started, an implementation of this image storage client will be injected into this artifact controller, so we can use it down here. Okay, thank you, Copilot. Perfect. All right, now let's define a concrete implementation of this image storage client, Azure Image Storage Client. And of course, it needs to implement image storage client. Recall that we added the Spring Cloud Azure Starter Storage Blob dependency in the pom.xml. It provides integration between Spring Boot and the Azure Blob service. How so? Spring Cloud Azure will automatically create an instance of Blob service client when the application is started. So we need to inject it into this Azure image storage client. Private final blob service client, and we need to inject it by constructor. This blob service client will automatically retrieve the Azure Blob Storage account name and account key and connect to the Azure Blob Storage on our behalf. So this really simplifies our job. All we need to do is to use this blob service client. All right, so let's do that. So first, the blob service client dot get blob container client, and we have the container name. So basically here we are initializing a blob container client object pointing to the specified container, in our case, the artifact image container. All right, next, we need to rename the image file before uploading, because it's very common that two users will upload two different images, but with the same name. If we do not rename the images, then one image will override the other one, since they have the same name. So it's always good practice that before uploading, we rename the image by giving it a unique name. So here is a simple way to create a new unique name for the uploaded image file, is that we can combine a UUID with the original file extension. Here is the syntax. UUID dot random UUID dot toString, then plus original image name dot substring, and this recommendation is good. Yes. Let's call this new image name. All right, next, let's get a blob client to interact with the specified blob. Blob container client dot get blob client with new image name. So this line gets a blob client object to interact with the specific blob or file identified by new image name. And finally, we can use this blob client to upload the file to Azure Blob Storage. Basically, this line will create a new blob or update the content of an existing blob in the container. And don't forget to return blob client dot get blob URL. If the upload is successful, then this line will return the URL of the blob represented by this client. Okay, so let me quickly add some comments here for your reference. By the way, here true means this file should overwrite any existing blob with the same name. And hopefully this UID will give a unique name to every blob. Okay, we're done. All right, don't forget to annotate this class with @service. Okay, great. Since we changed our code, let's test locally first. Okay, all tests passed. Next, let's go to Postman and upload an artifact image. Let me first start my project. Okay, then let's go to Postman. First, we need to log in as John, and here is the password. Okay, great. Then let me copy this token. Copy. Let's create a new HTTP post request. The URL for uploading images is localhost API v1 artifacts images. And then for authorization, it should be bearer token. Paste. And then let's go to body. Recall that we should pick form data with two values. The first one is container name. It is artifact image container. And the second one is file. Then how do we upload the file in Postman? So let's come here and click File. And here we can click Select Files. And let's go to Desktop, Images, and click Remember.jpg. Click Open. All right, so now it's attached to Postman. Now next, I'm going to click Send. Let's see what happens. Great! Upload image success. And as you can see, this is the returned URL. Let's go to Azure Portal to verify this. So here I'm in the container. So let's click Refresh. Okay, great. Now there are two images. Now recall that this one we uploaded manually by clicking this Upload button, and this is done through Spring Boot and Postman. Let's go back to IntelliJ. Next, we need to consider exceptions handling, because the blob upload may fail, right? So let's go to the upload image method in Azure Image Storage Client. Okay. So let me cut this and put it in a try catch. If bad things happen, the try block will throw a blob storage exception. This blob storage exception class comes from Spring Cloud Azure. It is used to handle exceptions that occur while interacting with Azure Blob Storage. This exception class provides detailed information about the error that occurred, including the HTTP status code and error message. After catching this exception, let's throw a custom blob storage exception. And then we pass two parameters to it. The first one is a message, failed to upload image to Azure Blob. Storage. And the second argument is the exception itself. Now, apparently, we don't have this yet, so let's create this custom exception. Recall that we define all the custom exceptions under System, Exception. And thank you, Copilot. So this is perfect. Close this and make sure we import it in the Azure Image Storage Client. Now, Spring Boot needs to properly handle this custom blob storage exception. And how do we do that? We can use handler advice. So let's click here and scroll down here. And here, result, handle custom blob storage exception. Good. Thank you, Copilot. Here, let's define @exception handler @response status. Cool. But let me verify the AI generated code. All right. Now our development is done. As the very last step, let's consider accessing Azure Blob Storage during production. As you can see, I already have the application-prod.yaml file open. Our production Spring Boot application will use this configuration file to access the Azure Blob Storage. So let's define the credentials as properties in this YAML file. Storage, blob, account name. So let's set this environment variable in Azure Web App. Let's go to Azure Portal. This is the Azure Web App that hosts our Hogwarts Artifacts Online Spring Boot application. Let's create an environment variable. Let's go here, click Environment Variables. As you can see, there are already 3 environment variables: Azure Key Vault Endpoint, Spring Profiles Active, and Websites Enable App Service Storage. Let's create another one. Add, and the name is, copy paste, Azure Storage account name, and the value is Hogwarts Artifacts Online. Apply. Apply. Confirm. Let's go back to IntelliJ. What about the account key? Recall that in application-dev.yaml, we defined this property, account key. Well, it turns out that we don't need it in production. You're like, what? Then how does the Azure Blob Storage verify who you are? Take a look at this picture. As you just saw, during production, our Spring Boot application is deployed as an Azure web app. That means both the Spring Boot application and the Azure Blob Storage are resources hosted on the Azure cloud platform. So, accessing the Azure Blob Storage during production is different from the development, where our Spring Boot application is hosted on our local computer. On the Azure platform, access to a Blob Storage account still requires proper authentication and authorization. The Blob Storage account authentication is done via Managed Identity and Microsoft Entra ID. Authorization is done via Azure Role-Based Access Control, or RBAC. In a previous video on Azure Key Vault, we have already enabled the system-assigned managed identity for our Spring Boot Azure web app. As I said before, the managed identity is authenticated with Microsoft Entra ID, so you don't have to store any credentials or keys in the application code. That's why there's no need to include account key in the YAML file. That's for authentication. As far as authorization, let's go to the Blob Storage account. Let's click Containers, Artifact-Image-Container. We're going to grant our Spring Boot web app access to this container. So let's click Access Control, click Add Role Assignment. And here, let's search Storage Blob Data Contributor. So this is the role. Let's click this. Now here the description says, this role allows for read, write, and delete access to Azure Storage Blob containers and data. So let's click Next. And let's click Managed Identity. Select Members. App service, there's only one app service, which is Hogwarts-Artifacts-Online. Let's click this. So basically, we're going to assign that role, Storage Blob Data Contributor, to our Spring Boot web application right here. So click Select, Review and Assign, and click Review and Assign again. Okay, as you can see, our web app was added as Storage Blob Data Contributor. Very good. So now our Spring Boot web app deployed in Azure can upload images to this container. Then let's click Role Assignments here to double check. Now, as you can see, our web app is a Storage Blob Data Contributor of this container. Very good. Next, let's go back to IntelliJ, commit and push the code to GitHub. In the application-prod.yaml file, I've added line 11 to 14 to limit the max file size and max request size for production. Now let's commit and push the code to GitHub so it will trigger a deployment to the Azure web app. Implement upload image to Azure Blob Storage. Git push. Okay, then let's go to GitHub. All right, so let's click Compare and Pull Request. Create pull request. Now this one triggers Java CI with Maven. So let's go to Actions.
2,000 years later.
All right, then let's go to Pull Requests and merge pull request. Let's go to Actions. So this will trigger the deployment.
2,000 years later.
Okay, great. The deployment is successful. Next, let's do a test in Postman. Okay, let's test in Postman. As you can see the URL, this time we're making a request to the production server. I have already logged in, got the token, and put the token in authorization. In body, we checked form data, and here we're providing two values: container name, which is artifact-image-container, and also the file. So let's select a file. Now this time, let's upload the deluminator.jpg. Okay, now let's click Send. As you can see, Upload image success. Then let's go to Azure portal to verify. All right, let's click refresh. Okay, this is the image we just uploaded. Let's go back to the slides and do a quick summary. In summary, in this video, I showed you how to set up the Azure Blob Storage by creating an Azure Storage account and a container. Second, we configured Spring Boot application so that it connects to the Azure Blob Storage. This includes both the development and production mode. Third, in the Spring Boot application, we wrote code to receive the image file from the front end and then upload it to an Azure Blob Storage container using Spring Cloud Azure. I hope you learned something in this video. See you in the next video.